Hello friends, welcome to my channel. After we designed this supply architecture last time, as an exception, I would now like to show briefly, that you can simulate this circuit if you have the models in the corresponding tools. Such methods combined with worst-case analysis, for example with MathCAD, we will tackle in the future. These are important means to secure the hardware errors, before investing money in the PCB equipment. If desired, I can simulate the complete circuit with the free tool T-Spice. Now, I will use TNet Texas Instruments, because for these components, I can find the SPICE models in the internet. But the free TNet tool is limited by the number of simulated components, so I can only simulate parts of the circuit. This was just a reminder that there are many ways to secure your hardware before investing money. In our case, we will only use such methods here, because I am not yet able to invest in my videos. My goal is to use the money from YouTube in the future, to invest in videos again to teach practical skills. But important in the first moment, is to learn how to develop automotive systems before real testing. From today on, we will take care to implement this hardware architecture. Step by step, we will go into detail. Today, our goal is to protect the hardware. The 48V safety circuit allows the DC-DC to completely disconnect from the 48V battery rail, using field effect transistors. The block also protects the DC-DC against overvoltage and overcurrent. Our 48V safety circuit conducts and disconnects current up to 50 ampere, in both directions for voltages up to 70 volt. The ability to disconnect current flow, in both directions is generally required, therefore, a back-to-back MOSFET's configuration is used. This requirement is also beneficial, for example, free charging the 48V side capacitors to the KL40 voltage, reduces the inrush current during turn-on. Selected MOSFETs have a very low RDS(on), and are rated up to 100 volt. MOSFETs are in parallel, to further reduce losses, caused by RDS(on). To turn the gates on and off, fast enough, the LM5060Q1 device is used. TVS diode D405, and a group of capacitors C400 through C405, comprise the board-level input transient protection. The TVS diode is bidirectional, to allow the input to withstand the reverse polarity condition. Capacitors in series reduce the probability of a short circuit in case of single capacitor failure. In the boost mode, we need LC filter on the 48V voltage rail, mainly to help us to reduce output ripple. After designing the 48V switch breaker, protection and filter, in the next video, we design the protection circuit for the 12V trail. The disconnect feature is also needed here. Don't forget, as I said several times back then, in Facebook I accompany my designs with preparations and tips. Thank you for watching. Please don't forget to like and subscribe.